problem we want to be able to put into one of the inverse trig forms. And so this one here, this 2 is really not a problem, but we want to get a perfect square plus a perfect square. Well, if I separate this out, I have 4x squared plus 16x. And I just need an x that's going to make this a perfect square trinomial. And to make this a perfect square trinomial, I can write that as 16, because x plus 2 squared, x plus 4 squared will give me this expansion. So there's my perfect square, and that leaves me with a plus 9 because I need a plus 25 here. So I have a perfect square plus a perfect square. Well, that fits into my arctan form. So I'm just going to rewrite this first. 2x plus 4 squared plus 9. I can now integrate that to get the antiderivative. So bringing that 2 onto the outside, this just fits my arctan perfectly in that my a value is 3, so maybe I'll rewrite this. So I have 2x plus 4 squared plus 3 squared. My a value is equal to 3, so it becomes 1 over 3. So I'm going to write 2 times 1 over 3 arctan. The inside part is going to be 2x plus 4 over 3. I have to remember that there's chain rule involved here because I have a times 2 here, so I need to divide by 2. So I've accounted for that extra times 2, and then make sure I have a plus c. I can simplify this a little bit more. The 2's cancel out, so I end up with 1/3 arctan 2x plus 4 over 3, and then plus c. So there's my antiderivative for this integral that I started with here. So this function, I just need to put into the arctan form by finding a perfect square quadratic plus a perfect square.